In this lesson, we'll be using the single groove toolpath in Fusion 360. After completing this lesson, you'll be able to create a single groove toolpath, modify tool parameters, and use Simulate to verify a toolpath. To get started, we want to upload the supplied file, Turning Grooves. We want to navigate to the manufacturer workspace. We need to create a new setup for mill turn. We're going to make sure that the stock size is appropriate and that the coordinate system location is good. Notice that these parameters are all metric. This is because our file is currently set to the units metric. I'm going to cancel this and modify the document settings to make sure that we're using an inch type. When you go into your user preferences, there are going to be default units for the design as well as default units for manufacture. So even if you reset your default units for your design workspace, you want to make sure that you reset your default units for your manufacturer workspace if you're consistently working in inch or metric files. Once our units have been reset, we're going to go into our setup, again using a mill turn. Then we want to make sure that our stock is an appropriate size and that our coordinate system is in the right location. We are going to be basing this off the front of the stock, and then we're going to navigate to our stock setup. We're going to be using a fixed size cylinder, 3.5 inch outside diameter, and we're going to make the length 4 inches, and we're going to offset it based on the front. So I want to add a small amount to the front, just so I have enough to face the part and get started, but we want to make sure that the majority of the offset's on the back, so that way the chuck can actually hold the part. We're going to go ahead and say OK. And now we've created our new setup and our stock. In this lesson, we're going to be exploring the single groove toolpath in Fusion 360. So from our turning dropdown, notice that we have turning single groove, and then we also have multiple grooves. So we're going to be using the turning single groove and take a look at the options we have inside here. I do want to note the size of our grooves could differ depending on which geometry we're cutting. Also note that my camera mode is set to perspective with ortho faces. You can change your display settings by going into Display Settings, Camera, and turning it to just an orthographic view if it helps a representation for you. We can also use Inspect Measure to get an idea of the size of some of our grooves, but note that does kick us out of the operation that we were creating. The distance between here is 0.188. So this way we have the information for when we're creating our single groove. We're going to take a look at the tools, going into our samples library, and we're going to be using a square grooving tool. We have one for the OD, and if we take a look at the information, you'll notice that it's a metric tool. We're going to say OK for now. We might need to create our own tool or modify its parameters. We're going to be using it for outside grooving. And then we're going to go into our geometry section and note that we need to pick the groove positions. We can select the groove location and note that the alignment can be middle, back, or front. Each of these will have different implications based on your selection. So back will offset the tool from the selected groove geometry in the negative Z direction toward the back side of the stock. Front will offset the tool from the selected groove geometry toward the front side of the stock in the positive Z direction. We also have our radii values, which will control the outside and inside locations where the tool can go, as well as its clearance and retract planes. And then in our passes section, we have some options. We can use pecking, we can dwell before the retract, and we can also allow rapid retract. If we want to use this as a roughing operation, we can also tell it a small amount of stock that we want to leave behind. And then we have linking parameters. Notice that there aren't as many linking parameters here as there are for something like a profile. So let's say OK and see what we've created. So as we take a look at this from our top view, we can see the yellow preview of the profile, and we can see exactly where we've cut. Because the tool isn't perfectly square, we aren't able to get into that square corner. And because the width of the tool is not matching the width of our groove, we aren't able to completely cut this groove with this operation. The single groove tool will allow us to come in and create this cut, but again, there are some parameters that are going to be affected. If we edit the tool itself, we can modify the parameters of the tool so that it does exactly match the groove. Now again, you would want to do this if you're working directly off of a purchase tool or if you're cutting your own tools. We're going to set this to inch, and we're going to take a look at the groove width. Now remember, our groove is 188, which is actually going to be 1875 based on the rounding values in our inspect measure. We can modify the rest of the parameters if we want to reduce the corner radius, for example. And again, these values will come directly from a supplier tool. I'm going to go ahead and say OK, adjusting those parameters, and I get a warning telling me that the operations using the tool need to be updated. So I'm going to override those and update the tool, and then I'll use Control-G to regenerate. Notice once it's regenerated that we do have a slight adjustment here. I'm going to simulate this toolpath, and I'm going to play through and take a look at it. If we change the stock to transparent, we can now get a view of exactly what's being cut. The tool now exactly matches the width of our groove, but we still have a small radius to contend with. If the actual geometry does need a square cut, it'll be a very specific tool that needs to be used. However, this gave us the cut that we needed based on the modifications we made to the tool and the toolpath itself. Notice that we didn't do any profiling or roughing of this geometry first, and in reality that is going to be the first step, but what we want to focus on and explore is going to be grooving toolpaths. So for right now, let's navigate back to a home position, and let's save our file before we move on to the next step.